Good morning to all. Good morning, students. Please switch off your camera.
मॉर्निंग सर।
गुड मॉर्निंग जी।
सर सर वो सिचुएशनल अवेयरनेस वाले नोट्स आप सर वो ड्राइव पे डाल देना जो आपने करवाए थे ना।
सिचुएशनल अवेयरनेस।
हाँ जी,
ओके।
वो भी सर। ठीक है।
सिचुएशनल अवेयरनेस।
Gracefully.
ठीक है, डाल दूंगा। लेट मी ट्रैक इट। I'll put it, no problem. Okay, in the meanwhile, we can continue with our discussion from yesterday. We had seen the hatch covers, the operation part, and now what we are remaining is the idea about testing of hatch covers against leakages, etc. So we'll continue with that. Now, of course, you're involved with this because, okay, you have loaded cargo, you have closed the hatch cover, you have deployed the cleats, and you're assured that the hatch cover is sealed. But what about the actual testing and weather tightness? Although you have employed the right method, everything is closed now, cleats have been deployed, but you still need to find whether this hatch cover, what you're going to use to carry cargo, is weather tight or not. So we had seen the point about difference between weather tightness and water tightness. To put it straight, hatch covers are to be weather tight. They are weather tight, which means they're supposed to be weather tight. which means that water cannot enter the hole. After the hatch cover has been sealed with methods as per the procedure, water cannot penetrate into the hole. That is water tightness. And of course, when you talk of water tightness, the water cannot enter or exit the hole. That is the difference. Just want to ask in the class if anybody has sailed on a bulk carrier which used to carry ballast in cargo hold, maybe for emergency, no, not emergency, as a ballast in the cargo hold. Anybody with experience like that, where he has carried ballast in the cargo hold? Means cargo hold is turned from cargo mode to ballast mode, and then ballast is carried for that particular voyage for the purpose of stability, SAPM stresses. Some ballast is carried, which is not unusual. It happens all the time. So anybody with that kind of experience, I'm asking for a purpose.
No, sir.
Okay. If you do happen to carry water ballast as a normal thing, as a normal procedure to make sure that you are having the adequate draft, propeller immersion, etc., then you will notice that while the ship is in motion and moving, in this particular from this particular hold, you can see water coming out. If it is full, ballast is full in the hold, you can see by motion, by rolling or pitching, water comes out because that is the weather tightness. It can allow water to come out. So it can be clearly seen in such a case that the hatch cover is only weather tight and water does come out. After sloshing around inside the hold is full of ballast and some water can be seen, ballast water can be seen to come out of the opening, which is the ceiling, which is around the edges of the hatch cover. You can see some water coming out because it is weather tight. So it will not allow water to enter, but it can allow water to come out because it is only weather tight. If you compare this with watertight covers like manhole covers of a DV tank on the deck, maybe you got a wing tank, topside tank, and you got a manhole cover on top on deck. In this case, the manhole cover is watertight and you will not see any water coming out through the cover because it is watertight. So of course, when you talk about testing the hatch covers for weather tightness, several methods are available. Let's have a look. The first one is to, you know, you sight the cargo as soon as the hatches are open, you see any signs of water damage. So if you see water streaks or stains on the inside of the coamings, then it is clear that the hatch cover is not watertight and some leakage is taking place. That is the first way to judge whether the cover is either watertight or not. On opening the hold, as soon as the covers are open, you can look for signs of water damage or for water streaks or stains on the inside of the coaming. That will be a clear indication that this particular hatch cover which you are inspecting is not really watertight. Something is going on. So this is one ingress leak test after opening the hole. Another method employed very commonly because it is simple and does not cost much is this one: water hose leak detection test. Water hose leak detection test. So very simply, you got a hose, fire hose rig, got the fire line running, and then you point the hose towards the places where you feel water could ingress. Like this one is the cross joint. So water could leak from here. You direct the hose to this opening. Obviously, you're not expecting water to go inside, but this is only a test. And this should be done actually preferably unloaded, because if suppose there is an ingress or that is not a foolproof, then maybe you can cause cargo damage if you're testing like this and water does go in. So this should be preferably carried out when the cargo hold is empty. As a matter of fact, such tests should be done on a rotational basis. All holes cannot be inspected, all hatch covers cannot be done in one go. So you mark in the port where this can be done at sea also, provided the weather is okay. You can do it at sea also when the cargo hold is empty. For which reason you will need to just be very sure that this is followed. What I will tell you what. This is actually the most commonly applied test. This one with the hose, this is the most common test because, as I said, it is cost cutting. It does not cost anything. It is only water being supplied through the fire line, and nothing is being involved in cost. So, obviously, you will need to consider what your class says about this. But generally speaking, a pressure of 2 to 3 kg per centimeter square should be applied through the hose whose diameter is to be 20 to 30 mm. The diameter of the nozzle is about 12 mm. And distance, this one, the distance, this distance from where you are having the hose directed towards the opening should be about 1 to 1.5 meters. And it is supposed to have a dynamic test. So you move the uh, this hose at a speed of 1 meter per 2 seconds or something to show any leakages in dynamic condition also. Kindly note, kindly note, you will need to mention this. It is not enough to just describe the water hose test. It is important to describe what pressure, what distance, and the diameter of the nozzle, etc. इसको एक note बना लो. Make sure that you understand in the way that you will need to quote by this.
सर इससे ऊपर वाली एक बार स्लाइड दिखाना प्लीज।
Here, this is only a picture, so I don't think you are looking for this.
ओके सर डन।
Okay. Please note in the ingress leak test, actually you're not doing any test. What you're doing is an inspection as soon as you have opened up. Only an inspection. From there you can lead to a test because if you see some signs, then you want further action to be taken. So this is only a static test, which is only by visual inspection of the cargo. Then of course this one we are talking about water hose leak detection test, which can be done like this. For which reason, in an answer you will need to mention all this. Pressure of 2 to 3 kg per centimeter square, hose diameter is 20 to 30 mm, 12 mm nozzle diameter, distance 1 to 1.5, and of course moving along at a speed of 1 meter per 2 seconds. Like this hose is supposed to move. You don't hold it stationary. The hose is supposed to travel with an estimated speed of 1 meter per 2 seconds. And this will constitute what is called the water hose test. Some limitations for this test, the water hose test is like this. You can damage cargo if it is loaded. Because if the hatch cover is not weather tight by any chance, then you can damage cargo inside the oil. So this should be very carefully done. As I said, you should take a preference to do this only when you are in ballast passage or the hold is empty. Maybe partly loaded, this hold is particularly empty, so you can carry out the test and then log it out. As I said, you cannot do all the hatch cover tests in one go, so you can stagger it out. This voyage, this hold is empty, you test it out. Then next hold, whenever it is empty, you test that one out and keep entering in your PMS. Of course, if the temperatures are sub-zero, then this test cannot be done because water will freeze. Again, the third point that it requires text couple drains to be open to clear the deck of excess water which is spilling out from the hatch cover is also a concern. Why? It is a concern. Why? Any thoughts on that? You need to have the text couples open to clear the water which is pouring down from the hatch cover onto that mid deck. But why is it a concern? Why should it be a concern? For a simple reason. If you have any stains of oil, this is going to cause pollution. So either you make sure that your deck is spotlessly clean, or you will not able to do this, because if the scuppers are open, which should be open, then you can have a concern by oil flowing past, or maybe some sheen developing on the ship side. So marble concerns could be there, but minor concern. I'm very sure that you will make sure that everything is clean before you actually do this test. Yeah, of course, this one is there. Just as we said here, you could contaminate harbor water from deck debris or oil. So this is something very necessary to make sure that you're not causing any MARPOL violation while carrying out this test. As I said, it is a minor concern, but if it does happen, it is a huge concern. Because you're going to do this, let us assume, in a port, in a harbor, where everyone is watching, where you can be easily identified as the ship which has caused the contamination of harbor. Now, one disadvantage of this test is that although you're doing this test, not costing any money, you're moving this hose along like this on the cross joint, but somebody is there inside the hole to see if there is any leakage or is there any spill of water from the deck, right, from the hatch cover, but it cannot pinpoint from where exactly the leakages are occurring. Unless a very well illuminated, on the flip side, a very well illuminated hole inside, somebody is standing, and when you're carrying out the test, he's watching. The person inside the hole is watching exactly from where the water is dripping. Then you can pinpoint, but again, it will require a lot of communication to make sure that you're conveying to the person on top who's carrying out the test that this exactly is the place from where the hatch cover is leaking. One another method, again very commonly used, is a chalk test. The chalk test is actually may not be acceptable because the surveyors may not exactly be happy with this. Water hose test they do agree. External surveyors, during a survey, continuous hull survey, hatch cover surveys, they may accept the water hose test, but chalk test, many of the external surveyors are apprehensive about it. But it can be done. It can be done if you are doing it on board for your satisfaction. You can do it. Chalk test. So this one is actually relatively simpler. No water involved, no chance of damage of cargo. If water is leaking, no chance of that. Chalk test. So we have seen the compression bars. You can recall what is the compression bar, right? So you take pieces of chalk and then smear on the compression bar the chalk. The surface of the compression bar, the top part, you put chalk all around. After that, you close the cover. When you close the cover, the rubber backing of the hatch cover is going to come in contact with the compression bar, and of course, you will close it as if you are sealing for seal. So you close it, seal it, put the cleats, and then this chalk which is on the compression bar is going to make an impression or is going to leave an imprint on the rubber sealing. Open it to see that the chalk mark has been left in all parts of the sealing material, which is the rubber backing. No breaks in the chalk mark. The whole thing is completely marked. Impression is there of the chalk all around. Then you know that the hatch cover is seating properly. Now this is a good test actually. Why? Because no water is involved and can be done with minimum manpower. Of course, you require people to open the hatch cover and close it, but minimum manpower. This is a very preferred test to be done in harbor with no concerns about barcode violation, etc., and to be recorded in PFS chalk test. Also, this test is used, the chalk test, when you have carried out some repairs. For example, we had seen photographs of compression bar which are distorted. Compression bar, then we had come to a conclusion that one way to do it is to crop and repair. So you crop that part of compression bar which is disintegrated or is showing signs of, you know, breaking up, and then you can carry out this test after the compression bar has been renewed. This is a good test to do to check the alignment after some repairs have been done. But otherwise also, I have personally used this chalk test on board to carry out, you know, uh, initial investigation that the hatch cover is weathertight. Now, if an impression has not been left on the rubber backing, then you got a concern. Then you move on to another test, which can be hose test, if there is a concern. So this could be an initial test, which would be, telling you if there is a concern. Strongly recommended. The chalk test is strongly recommended whenever you have carried out some repairs or renewals. It is very strongly recommended. So at least the alignment of the hatch cover panel with the combing and compression bar can be ascertained straight away. If you got concern, you move on to post test. Again, the chalk test is not going to tell you is the weather tight integrating maintained or not, because it is only going to give you an impression that somewhere maybe the hatch cover is not sitting properly, which is the alignment. The alignment is not proper. But it takes care of some drawbacks which are applicable to water hose testing, which is including some pollution or maybe cargo damage due to leakage. Those limitations, drawbacks are taken care. The water hose testing limitations are taken care in chalk test. Again, yes,
वो
please.
स्लाइड वो सर स्लाइड दोबारा करिए, लास्ट वाली स्लाइड, लास्ट वाली।
Okay, okay. Please, you want the last slide again? Okay, no problem. Tell me, ये वाला chalk test.
सर वो नीचे है, वो नीचे, ये सर। ये सर ओके।
Okay, जी, okay. By far, the most effective, approved by class also, is this test. It is called this one, ultrasonic leak detection test. The most preferred one by the class surveyors, by inspectors. This they believe. Ultrasonic leak detection test. This verifies weather tightness and also hold access cover seals. But of course, it has to be done with a class approved equipment. But this is very much preferred and approved. Everybody believes this one. Ultrasonic leak detection test. Just give me a minute. I have a better slide to show you for this case. Just give me a minute. So one thing, weather tightness under dynamic conditions, which is when the vessel is moving, water is not going to infiltrate or penetrate a hatch cover if there is a physical contact between the packing rubber and compression bar. So this is the basic. If there is a contact between packing rubber packing and compression bar, then there is very little chance water is going to penetrate the hatch cover. But then you have to be careful. It should be only touching, slightly touching. If the packing rubber is bearing heavily on the compression, then it will not make a difference, and also it will get compressed unnecessarily and make a groove. Subsequently, in multiple uses, not in one use but in subsequent uses, it may allow water penetration because it has already caused a indentation in the packing. So if the packing is showing deep permanent set or imprint, this may lose its resilience and sealing performance because now the groove is there and that groove will allow water to penetrate. So it should be only touching. That is the main point. Also, to achieve weather tightness in dynamic conditions, packing rubber should exert a equal amount of compression on the sides of compression bar, all the sides, equal amount. You see, if there is a pressure exerted by the packing rubber over here, but not equal over here, then there can be a gap.
सर इस टेस्ट में ये लिखा है कि पता चलता है कि कहाँ कहाँ पे सीलिंग कॉम्प्रोमाइज हुआ है, वो कैसे पता चलता है?
In the ultrasonic पे अब जाना हमने.
ओके ओके।
We have to come here. We are going to come here. Right now, we are just discussing this part, whether tightness under dynamic conditions. But if you're talking about that you can identify the place of leakage, that is ultrasonic. We are coming to that. उसके बारे में बात करेंगे.
ठीक है सर, ओके.
Now, a more simpler photograph what we already saw for the hose test, right? Hose test. This should be moving. This should be moving, not static in one place. Only then acceptable. You should have a pressure, and then it should be moving. This is simple because you can get this done on board, but the concerns which we have already seen, like marble violation, because the water is going to go and flow out on deck. If there is any debris or any oil sheen on the deck, this can go out because the scuppers are open. You understand scuppers, right? The scuppers on the main deck which allow water to be drained out. You normally close the scuppers in port.
Yes, sir.
Okay. And why do you say yes? And why do you close? By your thoughts. Actually, scuppers का use क्या है? What is the use of scuppers? Drainage, drainage of water, right? Why you said yes was because you're trying to make sure that nothing except water goes out. So you seal it in port, but it is a it is an unlegal act. मतलब this can be penalized by the PSC because the scuppers are never supposed to be closed. They are there as a load line item. Free spring ports or scuppers are supposed to be there to allow water to be drained out. We are in the achievements class. So can you tell me if water does collect because scuppers are blocked or scuppers have been choked, what happens? What is the concern if scuppers are blocked? And think about it in context of load line. Why the scuppers should be free and should allow water to drain down. Suppose it is choked, then what is the problem? What is the concern? As far as scuppers blocked, water is not flowing out. What could be a concern?
So GM will be reduced.
Why you say that? Okay, I agree, but why? GM reduced straight away because scuppers are blocked. GM को पता लग गया scuppers blocked है.
No, sir, because it will because the water will accumulated on the deck, and if
Okay,
sufficiently water will accumulate, then G will shift it upward, and that will cause reducing GMs.
absolutely right. What we are looking at is the free surface effect, FSE, created because water has accumulated on deck. And if it is a very large area of deck, maybe a capesize or something, then you got a concern because this is going to set free surface correction in motion, free surface effect, right? That is going to alter GM, that is going to be reduced from the GM solid. You are aware of this. So this is a concern, which is why it is a load line item. You cannot have the scuppers blocked. And let me assure you that there are cases if a post state control is visiting and they see the scuppers blocked, you are in problems. They can take serious objection to it because they are not supposed to be blocked. If you say or if you tell him that you have blocked it because of concern of oil going overboard, then his idea will be stop the flow of oil. Get to the root cause why oil is on deck. But you cannot block scuppers.
Sir, but this there is in ship shore safety checklist and all the tankers. It's written we have to close the scuppers,
Okay,
and only for draining rainwater we can open it, and it should be manned when we open.
okay, okay. So you are talking about your SMS procedure, right?
Yes, sir. Most of the ports are saying that
Okay.
you have to close the scuppers.
then it's okay. If it is by requirement from the port, it's okay. If it is a requirement from the SMS, it is okay. But I was trying to interact with you and discuss with you why scuppers are there in the first place. So somebody has rightly remarked it is there to make sure there is no free surface created because of accumulation of water on deck. That will be there. But if your SMS procedure or if the port requirement says that you have to block it, okay, then you got to back it. This is why you have done it.
Sir, we can't open it because otherwise, if oil pollution is there, how we can stop it? And even for bunkering, also we have to keep the scupper.
Closed. Okay. But then you open it once the thing is done, once the bunkering is over, then you open it. You can justify to a PSC inspector that you had closed it for safety reasons because your bunker is in progress. But after the job is done, open it again because the
Yeah, that
scupper
is
is there.
operational requirement, sir.
Okay. The scupper is there, I can assure you, for the purpose of what somebody has just not described, to make sure no free surface is created. As it is, if scuppers are blocked, water is collecting on deck, you're adding weight on top, right? You're adding weight on top. Adding weight on top means the G is shifting continuously upward. So GM is reducing. Coupled with that, if you're creating a free surface correction, then GM fluid is further reduced, which can lead to you know concerns regarding stability. हाँ जी बोलिए say yeah please go ahead somebody saying something yeah now I can hear you but you're still broken go ahead Shashipal is it uh, mhm. ठीक है I got your point but you will agree with me that scuppers are provided for a purpose so if you're going to block them then you're going to defeat that purpose that you will agree right anyway कहाँ पे आ गए आप लोग बात बहुत करते हैं कहाँ पे आ गए कुछ बोल रहे थे कहीं और चले गए चलो anyway no harm I like this because chief mid class is supposed to be interactive. So no problem. Even if we are doing host testing and we have moved on to scuppers, it's okay. No problem with me. Unless you say a waste of time. So host test is an approved method, quite randomly used, I mean quite frequently used and acceptable. So this is done very easily as we have seen moving along a hatch cover joint, directing a powerful jet of water to the determine if any water passes through it. That we've done as host test. This is also going to show, the result is also going to show whether a physical contact between packing rubber and the bedding surface, which is compression bar, is there. Discontinuity of it or lack of contact is going to indicate that some water could penetrate. But obviously, as we had seen in the limitation, it is not going to pinpoint from where the leakage is taking place. This could be achieved. The pinpointing of the exact area from where the leakage is taking place could be achieved by ultrasonic testing. So in this one, place a transmitter on top of the hatch cover. In various places, you keep moving it and then measure the ultrasonic signal received in the space inside. You keep a receiver inside, ultrasonic test, transmitter is on top, and then you measure the signal received, which will give you an idea if the sealing is correct or not. Since you're moving this transmitter along, then wherever the signal is taking a break or you can see or identify that the signal is not correct, that is a place where it will be leaking. So it can recognize or give an indication of the area where the sealing system is compromised or is compromised. So first you calibrate it. You calibrate it by what is called an open hatch value. Transmitter placed in the hole, open, and then receiver on top, and you take an open hatch value just for calibration. This represents the strength of the ultrasonic signal that reaches the receiver in open hatch. 1 minute, let me see if I got a photograph of this. It should be there. So this is ultrasonic. Yeah, okay. So first you do a slight calibration of the equipment, and then you carry it out. So you go right around the hatch cover parameter, and then record from down below the signal received. Wherever there is good compression, no ultrasound will pass. Whenever there is a flaw, discontinuity, sealing system not proper, ultrasound will pass and be picked up by the receiver, which is down below in the hole. So what you do is, having calibrated it first, you can compare the signal received with the OHV, which is the open hatch value, to see and compare the readings. Now, of course, certain allowances are allowed, certain allowances. Variation, if about 10% of the OHV open hatch value is found, then there is lack of compression and will require further investigation. Okay, 1 minute. This is the equipment being used, ultrasonic, and Anji, saying something? This is how it is being done. Now, this will actually be advantageous because very little manpower is required. Now, the signal generator for ultrasonic test is to be placed inside the hole with the hatch cover closed. Now, a sensor is passed all around compression joints to see and read the value of receiver. Obviously, as we said, you have already done the open hatch value for calibration. Now you compare what is being received with the open hatch value and then come to a conclusion. This is one of the most preferred ones and very acceptable by class also. This one they take it seriously and they agree to it. Why one man can conduct this test? Why? Why is this? One man can conduct this test. Because you see, the transmitter or signal generator is inside the old. उसको छोड़ के आ गए आप. Then you got a receiver on top which you are carrying. So one man can monitor it. Very less manpower or rather no manpower required. ये अलग बात है कि this can also be construed. इसमें भी गोची हो सकती है. गोची समझते ना? Can this be manipulated? This test? Calibration हो गया सर्वेयर के सामने. Readings have been recorded. Now the transmitter or the signal generator has been placed inside the hole. Hatch cover is closed. And maybe you as chief officer and the surveyor are moving along, taking a reading at the receiver end. Can this be manipulated? small points are there. I am discussing this off the record. This is not to be written in the answer, just off the record. That ultimately, you see, you have to get your vessel passed. So you have placed the transmitter inside the whole tank top. उसके ऊपर दो तीन ड्रम रख दो. अब तो बाहर आ गए ना तुम विद दी सर्वेयर. आएगा ही नहीं सिग्नल. Please note, not to be mentioned in any academic answer. This is only practicality. What people do, sometimes do on old ships, just to have the survey pass, which is not a correct thing. I do not say, I do not advocate it's correct, but this is also done sometimes to get your ship through. Right? We move on. Since you are moving with the receiver all along the hatch cover perimeter, wherever the signal is showing a variation, that is the place from where leaking joint is. So this can pinpoint the leaking points from joints or holes for precise location. Now hose testing is eliminated because this is not going to have any, you know, spill of water, etc. So clean test, dry test actually, which has got no issues. The advantage. The question could say, enumerate, discuss the advantages and disadvantages of an ultraviolet test. Maybe. तो ये सब चीजें आपने दिमाग में रख ली for answering those questions. Normally, a hatch cover and a leak test and precision or maybe damages caused by cargo gear. This is normally question number 3 of your paper. Normally. Some limitations. Experience. Calibration. Yes. Equipment will require regular calibration, maybe once a year. And for this purpose, maybe your ship owner may have it in the SMS that the calibration has to be done ashore. So, if that is the case, then you have to send it ashore for calibration, which is normally the case. But more so, it is perfectly acceptable to get it calibrated ashore. There are many equipment you send ashore for calibration. This can also go with it. Tolerance test is not something we will talk about. We'll limit ourselves to hatch cover leakage tests. But then again, ultrasonic testing should be carried out with class type approved equipment. The equipment which has been approved by your class for that vessel and qualified operators, of course. This is perfectly acceptable as an alternative method to hose testing. Okay. Anything you want to raise for this hatch cover testing, etc.? Comparison we have host or ultrasonic testing up, which I think you can do it yourself also, but we'll go through it, no problem. very important to identify which part of rubber packing is over compressed or under compressed. Very important, because that is not going to provide proper sealing. So ultrasonic test will be used to identify which part of which particular location the concern is, because from there the signal will vary. Right. ठीक है, अभी के लिए अगर कुछ नहीं है तो नो प्रॉब्लम, we take a break, candidates. Kit Kat break, and we come and meet at 1015. Okay, 1015, and we continue.
Okay. Thank
Thank you.
you.
Okay. So just as a comparison, hose test and ultrasonic testing. Please confirm shared screen is visible.
Yes, sir, visible.
Okay, ji. Just as a comparison, you know, hose test is going to give you an idea what is the contact between packing rubber and compression bar. Ultrasonic will give you an idea areas where the compression of sealing is not good or is being compromised. Contact and compression are two different things, of course. Contact means that sealing rubber and compression bar is making a contact. Compression is when the whole thing has been sealed, cleats have been employed, then how is the hatch cover sealing being compressed? So test results of course will be different. Ultrasonic testing will allow hatch covers to be tested in static condition in port, but after doing the test, it will allow the tester or the operator to form an opinion. If the static test in port is not good, then of course hatch cover sealing will not perform well in dynamic condition, because dynamic condition will involve more stringent test or more stringent environment. We are looking at cargo worthy, means the ship is actually cargo worthy, possible to load cargo. That is, if the hatch covers are weather tight. Some more advantages of ultrasonic. Non-destructive, nothing is being altered, not even water is being used. Pinpointing the exact area of damage where lack of compression exists. So these are some benefits which you can remember, possible to be asked. Why is ultrasonic test preferred? What are the advantages? Do you understand why easy detection with pinpoint accuracy of damaged area or lack of compression where it is existing? How is ultrasonic testing permitting this or facilitating pinpoint accuracy? Because you're moving the receiver of the ultrasonic along the perimeter of the hatch cover. Wherever the signal is disturbed compared with the OHV open hatch value, then you can pinpoint if this is the area from where the compression, lack of compression exists. So you can point or you can come to a conclusion for the damaged area. Once the location is known, repair can be done. Ultrasonic is dry testing, no risk of damaging water reaching the sensitive cargo. because even this test could be done even if the cargo is loaded inside the hold, of course. That will, you know, provide uh, safety for any damage caused by water to sensitive cargo if loaded, or to river docks, pollution, etc. Now, this is another advantage cannot be ignored. Possibility of downloading test results, which can be provided to ship operator with a detailed test report, which is to be can be used as documented evidence that testing was done, apart from the entry you are going to make in the PMS, etc. While if you see post test, the only evidence you can have is by taking some photographs while the test was being done. But this one, ultrasonic, you can download test reports which can give the operator with a detailed test report and subsequently documented for further use in case of an inspection, survey, etc. Some operators prefer doing this test, ultrasonic, during the loading period but prior to going to sea, just to be very sure if they have concerns. Now, of course, because it is a dry test, no water involved, this can be done even with sub-zero temperatures. So temperature of the environment is also not an issue. The equipment can be repeated test, nothing gets destroyed. If it is a class approved equipment, this can be equipment can be reused without any problem. Some advantages. Okay, we move on to another topic. Also, something to do with question number 3. To quote unquote, this is a question asked many times. What are detrimental effects of improper loading and use of cargo gear to bulk carrier holds? This is a repeated question, and the word used is detrimental. What are the detrimental effects? Causes due to improper cargo handling equipment and loading or discharging. Improper loading or discharging, comma, improper handling of cargo gear. So the word used was detrimental in the question itself. What are detrimental effects? So very frankly, the first time I read the word, I was not aware of the meaning. So I had to actually go to the dictionary and see, and I found that detrimental is an adjective, which means tending to cause harm. That was the translation. If you go back to the past question paper, you can easily locate this question. It has come many times, multiple times. So let's talk about it. Let's get done with this one. So if there is some harm done to the structure of the bulk carrier, it can lead to loss of the bulk carrier also. Resistance, structural resistance, which has been compromised due to some damage done due to improper cargo loading, discharging, or maybe improper use of the cargo handling equipment itself. By the way, no harm in repeating it. Can somebody tell me how can you answer a question which says define bulk cargo? Define bulk cargo. What is bulk cargo? Examples are many: coal, iron ore, grain, etc. But what is bulk cargo? Any volunteer for definition of bulk cargo?
So the cargo which is unpacked and transport in a large quantity.
Not packaged and transported in large quantity. This is what you're saying, right?
Yes, sir.
Okay. So when you say large quantity, what do you mean? How can we come to a conclusion this quantity is large? Can there be a numerical for this? I mean, can there be a number for this quantum? So and so quantity will be called large. Can we come to a conclusion like this? To define bulk cargo. Okay, I will volunteer. It is defined as cargo consisting mainly of granules or likewise material which is loaded directly into the cargo compartment, without any intermediate form of containment. That is bulk cargo. There should be no packaging, of course, because no intermediate form of containment. For example, let me say you suppose you are transporting coal or iron ore, but you load this in container. Is it possible to load a container full of coal and then put the container on board? You can transport like that also. What do you say? कंटेनर को आपने खोला हुआ है, उसमें आपने कोल डाल दिया और आयरन ओर डाल दिया, and then you transport the container itself. You're still transporting coal or iron ore, but in a container. but that cannot be called bulk cargo. But the same cargo like coal or iron ore is loaded directly into the cargo space without any intermediate form of containment, then it is called bulk cargo. You get my point? Okay, we come back to our discussion. Detrimental effects for improper loading, handling, cargo gear on bulk carriers. Which is a question which I figured I said. Now, the whole thing arose because there was loss of many bulk carriers in 90 to 97. 1990 to 1997, lots of bulk carriers were lost at sea. When the bulk carrier was lost, there was inquiry conducted, obviously, and a conclusion was made that structural resistance is compromised on these bulk carriers due to some improper handling. Obviously, having come to a conclusion, then the code was developed, bulk carrier IMSPC code and BLU, bulk loading and unloading code, to allow safe loading and unloading and the use of cargo gear. So, first thing was structural resistance, the ability of a structure to withstand or resist a loading pattern. Of course, it is time dependent because this, although is good and the build in the building stage or once it is new ship, but it is going to have a effect over a time period, which will be deterioration caused by fatigue or corrosion. Structural integrity of the vessel will be compromised both by fatigue and corrosion. So indentations could be caused by impacts from cargo grabs or indentations. Now, if indentations are being caused by impacts of cargo grabs, just example cargo grabs or maybe bulldozers employed inside their hold there. Once indentation has been made, this is going to give rise to corrosion. Why? This is going to give rise to corrosion, indentation, because if any water seeps in and collects in the indentation, it is going to give rise to corrosion. Once corrosion sets in, it is going to have a structural breakdown. Also, incidences of coating breakdown on undersurface of the tank top plating is also because of the indentation caused on the tank top. You understand indentation, candidates? Indentation. So before we go into it, let's have a look at the general arrangement of a hold of a bulk carrier, like this. Somebody who has worked on a bulk carrier will easily recognize it, but it is also advantageous for somebody who has not done a bulk carrier, maybe put on a bulk carrier later on as chief officer. So this is the normal configuration of a hold of a bulk carrier. So this part is called the tank top, where the cargo comes in. This is called the tank top, which is denoted by A. Underneath this, you have what is called double bottom. This is the fore and aft. This you find corrugated transverse bulkheads on the fore end or the aft end, and these are the port and starboard ends. You may have a single shell, which is now becoming obsolete because that will mean the boundary is being shared with water. But you could have a double skin, which is the normal thing now. These are brackets. This is the hopper. And end brackets are here, denoted by E, and side shell frames is denoted by delta. This one is a side shell frame. Frame to strengthen the side shell. On top, you will have what is called a topside tank, possible topside tank, and you can have a cross deck strip, which is running from port and starboard. Cross deck strip, for crossing over, and this will have a void space also. That's the general layout. A section through a bulk carrier hold. So if you have got this in idea now, then we can talk about structural damages. As you can see, this is a tank top where the cargo is loaded. Any discharge is going to take place from here to start with. I mean, it is going to move down from top, but over here, the bulldozer is going to work to collect the cargo and the grass. Impact can be made on the tank top, which is A, and will cause indentation, means a grooving, which is going to penetrate, not exactly uh, make a hole, but indentations, which is going to affect the double bottom. In fact, if you examine a double bottom tank on a bulk carrier, conventional bulk carrier, many a times when you will go inside the bulk carrier and look up toward the deck head of the double bottom, you will see grooves made due to cargo damage, cargo handling. So damages could be done to the tank top, could the side shell, impact by the crab against the side shell, frame could be bent or frame could be damaged, and brackets could be broken, sheared off. So those are structural damages caused due to improper handling or negligent handling. Okay, keep this in mind as we go along discussion, because we'll need to keep referring to it. Iron ore is a heavy density cargo, and when it is loaded in top of the tank top, lower stool spaces, lower bulkhead plating, and side shell bracket connections are affected. Mechanical damage is likely to be higher in the lower region of the cargo hold, because this is where why you recognize why the incidence of mechanical damage to be likely higher in the lower region of cargo hold. Because that is the place, the lower part, where everything is going to happen. Mechanical bulldozers, excavators, crabs, etc., are going to have the maximum impact in this part, the lower region. You will find many a times negligent operators, careless operators banging the cargo crab over here, causing indentation. Candidates who have worked on bulk carrier will agree with me that it is a normal practice that after completion of discharge of a bulk hold, you examine the bulk carrier, examine the bulk hold for any damages, and make a record. Right? You go inside the hold every time you complete discharge to examine for damages. So, seawater exposure, cargo exposure, maybe sulfur, which is corrosive, can damage the structure or have a corrosion done to the structure. This is also a cause of damage. Protective paint could give way. You see, trade route, coal corrosiveness, frequency of cargo changes, type of corrosion protection used inside the cargo hold are going to have an impact or can limit or maybe cause damage, including the type of corrosion protection, which paint you are using for protecting the corrosion. By a study, International Association of Classification Society (IACS) concluded the most vulnerable areas are the bulkhead between number one and number two hole, because this is where the impact of pitching etc. takes place maximum. So it is essential to recognize that these are the areas to be paid special attention during surveys. If necessary, repairs, modification should be done. But of course, any modification, structural alteration, if done in any part of the vessel, hull has to be done under the supervision of class. Class has to approve it. Mechanical damages due to improper cargo handling can lead to pocketed indentation of whole structure. This, pocketed indentation, I'll go back to the diagram. Here there is an indentation done because of impact of the crab. This is going to make a groove in the double bottom also. Now double bottom, you will take water for ballast and this will affect the groove. This contact of the salt water with the groove, like a, you know, this is going to make a corrosive action. Corrosion will set in. So inspection of cargo hold should be done after completion of each discharge to recognize what mechanical damages have been done so far, and then you can be more careful in future. Improper driving of forklifts excess can damage access ladders, or this is very common, losing of bilge cover plates. It is quite a few times it is taken away during discharge. So much so that as you are watching cargo discharge being carried by a conveyor belt, suddenly you see your bilge plate on the conveyor belt. So to continue, we have recognized the construction single side bulk carrier, you know, which can lead to some damages because of improper handling or cargo gear. Now, this one is the one we were talking about, hull structural failure. Now, to continue, what could be other factors? Physical damage to side structure during cargo discharge, mostly discharge because loading is done through chute, but it also has implications. But normally, mostly the damages occur during discharge by use of grabs, forklifts, excavators, collection of cargo in the space. And then to continue, some other factors: deviation from loading plan, manual, deviations from loading manual. High density cargo is susceptible for damages because if you deviate from the loading manual, approved loading manual, this can result in overstressing of the structure. Kindly note it down. Deviation from the loading manual is one potential problems में नंबर एक ही है, deviation from the loading manual. Apart from the fact that we have talked about structural damage due to improper handling of cargo gear. So if you are not following the loading manual and exceeding the permissible limits, you are resulting in overstressing of the structure. This can lead to failure of the hull structure itself. By overstressing, very simply we mean hull girder still water shear forces or hull girder still water bending moment SWM, SWBM or SWSF are not retained, are not remaining within permissible limits. Then you have got a reason for damage done to structure. And obviously, as we are saying this, you have to recognize this fact that when you are overstressing, this is not rocket science, it will not show immediately. Repeated overstressing can result in a damage which can be later on seen. High loading rate. We'll come back to high loading rate. This can significantly affect the structure because overloading it within a very short space of time. High overloading rate. Sorry, loading rate. High loading rate, which is very common because the charterer wants to complete the vessel ASAP. So this should actually be taken care of by drawing up a loading plan and sticking to it. You should stick to the loading plan, which will match your loading and your deballasting operation. As a matter of fact, simply your loading and the synchronization of deballasting should be done very carefully. Because of not following this plan, you can result in what is called asymmetric cargo and ballast distribution, which means you are loading at one place and deballasting has not taken place underneath. Now you got a reason for localized stresses. Just a minute, we'll come back. This is asymmetric loading, cargo distribution, piled up in one place. So this is going to cause localized stress. And also here. This can be termed as asymmetrical cargo distribution. Asymmetrical cargo distribution. How can you control this? Of course, by following the loading plan, but otherwise it has to result in what is called trimming, correct trimming. So this can result in asymmetric distribution, can result in torsional loading, twisting of the hull girder itself. High loading rate. I'm sure you note it down. Asymmetric cargo and ballast distribution, not matching, not synchronized. Let us say, just as a very rough example, you are loading in number 3 cargo hold. Heavy density cargo, maybe iron ore, is being loaded in number 3 cargo hold. And underneath number 3 cargo hold, you have what is called, let us say, number 4 DB tank, which is full of salt water or ballast. So normally when you are loading in number 3 cargo hold, the number 4 DB underneath should be pumped out, deballasted, to avoid localized stress. Now if this is not matching, loading rate is very high, your ballast pump capacity is not matching it, then you will develop what is called asymmetric cargo and ballast distribution. Can result in hull structure failure. And to avoid this, one, you should have a perfect loading plan in order, and then you should be taking care that your ballast pumps are running to full capacity and are doing the job what is required. It should not happen that when you really require the ballast pumps, phone comes from the engine room that the seal is leaking, so we cannot use it. That is not possible. You will have to stop loading off fire. So when we are talking of piling up lateral cargo pressure of the transverse bulkhead, we are looking at this kind of thing. This one. Piling up, this is going to cause lateral pressure on this bulkhead. Actually speaking, if there is a concern about high loading, the only way to control it is to stop cargo operation. If the loading plan is not followed, see when you come alongside, you have exchanged information with the terminal, and they have and you have agreed on a loading rate. If that is being exceeded, then you need to stop. Any deviation from the agreed loading plan can lead to stoppage of the cargo operation itself, because this can any deviation from the agreed loading plan which the cargo foreman has received and signed, he is accountable for that. Any deviation can lead to structural failure also. So, irrespective of what repercussions you have, safety paramount, you can stop the cargo operation. Okay, we will continue because this is not going to happen so fast. Important question, full question.
सर ये जो फ्लाइट दिखाई थी ना, उसका फर्स्ट पेज दिखाना.
एक मिनट, जस्ट गिव मी अ मिनट, अभी चलते हैं. फर्स्ट पेज, जस्ट अ मिनट. Okay, we are looking at the first page. This is what we are looking at. First page is this one. Never mind, we are going to continue the discussion next class में. We can always come back. You can make a note what you want to repeat. No problem. But so far so good. We have just started the topic. It is not complete at all. The effects detrimental to bulk carrier improper handling. Right? Not completed, obviously. Anything else you want to raise for time being?
तो सर वो नोट्स दे देते सर आप।
जी, आप कह रहे हैं सिचुएशनल अवेयरनेस ना?
हाँ, उसके सिचुएशनल अवेयरनेस और चार्टर पार्टी के भी पेंडिंग है सर आपके, और डीआरआई के भी कंप्लीट नहीं है।
देख लेता हूँ मैं। डीआरआई तो शायद भेजा है मैंने।
देखा है सर, उसमें पूरा कंप्लीट नहीं है। उसमें पोटेंशियल हजार्ड्स वगैरह भी नहीं है और टाइप्स ऑफ डीआरआई भी नहीं है उसमें।
कल में तो फिर तुमने पढ़ ही लिया है।
तो सर वो तो पढ़ा तो भी वैसे ही याद थोड़ी होगा, वो जब 15-20 दिन बाद तो भूल जाएगा सर।
सर वो भेज दीजिए तभी तो याद रहेगा सर, नहीं तो भूल जाएंगे ना।
भेजेंगे, एक दो बार एग्जाम के टाइम देखेंगे तो सही रहेगा सर।
तो 3 बार पढ़ना पड़ेगा सर, इतनी सारी थ्योरी है।
अच्छा, ठीक है यार, ठीक है। एक मिनट थोड़ा सांस ले ले। मैं ये कह रहा हूँ कि यू विल नीड टू रिकॉल दिस एंड रिमाइंड मी। आई हैव अ क्लास इन द आफ्टरनून आल्सो। तुम्हारे सामने डालूंगा सो दैट यू आर हैप्पी।
ठीक है सर।
चलो ऐसा करते हैं, इसको रिस्पॉन्ड कर लेते हैं तो एटलीस्ट ये वाला सेशन कंप्लीट होगा एंड वी मीट अगेन आफ्टरनून में।